Okay, let's take a look at number 6. Julie designed a patio that's 25 feet by 40 feet. She places a terrace strip of uniform width with trees and shrubs around the patio. The total area of just the terrace strip around the patio is 504 square feet. And then it says, if x is the width of the strip, write an equation a of x that describes the area of the patio with the strip around it. What is the width of the strip? So let's just take a look at this. We have given a 25 by 40 foot patio. So I'll just draw that. I'd rather do that visually. 25 feet by 40 feet. And there's a terraced strip around this patio. So we're going to put a little, and she put some nice shrubs, things in there. And it says this, we're going to call the width of this strip x. This is all information that was given in the problem. So there's x around the patio. And I'm just going to erase this 25 and put that inside so we can see. And it says that the area of just the terrace strip, so just this blue shaded, just the blue shaded terraced area, that area is equal to 504 square feet. Now, there's two things that we want. We want to know an equation a of x that describes the area of the patio with the strip around it. And then we want to find the width of the strip. Okay, so the area of the whole thing, the patio and the strip, so we'll call that area total. That's going to represent the area of the patio and strip together, and the border, whatever you want to call that. Okay, and we know that x is the width of the strip, and that is the unknown. This is what we're trying to solve for. So we have the given, we have the unknown. The equation, the area is going to equal, well, the general equation is length times width. So let's take a look at this. So the total area, if we look at the total area here, that's going to be 25 plus 2x, that outside width, because that includes the strip. And this is going to be 40 plus 2x. So the area as a function of x for the total, if I do the entire thing, this big red rectangle, that is the whole thing, that is going to equal 40 plus 2x times 25 plus 2x. Now, the question is, what is the width of the strip? And in order to solve that, we need to do a little bit more thinking about this picture. So this is the total area that we just wrote, and that's going to actually equal, that total area is going to be the sum of this inside triangle, right, which is 25 times 40, and 25 times 40, that's 1,000 square feet in there. 40, that's 40 times 25, right? And then it tells us that this blue area, remember, was 504. So if I do 1,000 plus 504, that has to equal this expression for this total area. So I can actually say that that total area is going to equal 1,000 plus 504. That sum is going to equal the 40 plus 2x times 25 plus 2x. And so I have 1,504 equals 40 plus 2x times 25 plus 2x. Now you could solve this algebraically using the quadratic formula, or you can try factoring it and set it equal to 0, but we're going to do it graphically. We're going to let this side equal y2 and this side equal y1. And if we put those in for y1 and y2, where those two graphs intersect is going to be the point where the x satisfies this equation. Now think about it. On our y min and our y max, before we even set this up, we know that our y max, we want to see this line, y2 equals 1500 in 4. So I know I want my y max to be something like 1600. And honestly, I don't need to see the very bottom of it, so I could say y min is 1000. And if I do that, I'll probably get a reasonable amount. Now, what is a good guess to start off our x min and our x max? Well, this is a border. This is a border that has some trees on it. It has an area of 504. So I would say that, x can't be less than 0. So I'm going to start off with an x min of 0, and I'm going to say an x max of 10. Let's just see what we get when we do y min is 1000, y max is 1600, because I want to be able to see this line going across. And I'm just going to take a guess. I know x can't be less than 0, and I'm just going to guess maybe 10 is a reasonable border to just start with. So let's plug in y1 and y2, and I'll take a picture of my calculator once I get them in. Okay, so you can see here I have my y min and my x min is 0, my x max is 10, my y min is 1000, my y max is 1600 for the reasons I described on the last one. And here's the two, the y1 and the y2 that match our equation, okay, and the x wrapped around there. And here's our two lines. So here's y1 and here's y2. And the point that we're worried about is when are the two sides of that equal sign the same. So we have 1504 is equal to 40 plus 2x times 25 plus 2x. And we called this y1 and we called this y2. And we're saying they're equal. Well, they're equal when they cross that point there. So we're going to do a calc intersection point. And when we do that, we have to make sure that it says the first curve we need to have our star here, second curve we need to have our star here, and it will calculate the intersection point for us. Now you can see on this screen what I've done. I did calc, and then when you do that, there's a choice for intersection. And the first curve, I put a marker. I said that's the first curve, and now it's asking for the second curve, so you can see the markers on the other curve. And then I'm going to hit enter, and when I hit enter, it gives me an intersection point. So it'll say down here, it'll say down here, after you hit the second curve, yes, and you hit guess, you can just hit enter when it says guess. This will change to intersection, and it'll give you the x and the y values. So mine says x equals 3.5 and y equals 1504. Okay, now that has to be the intersection because this intersection point right there, that point right there where these two lines intersect, it has to be on the y equals 1504 line. That's what we set it as. But this is the solution for x. And so the answer is that the width of the border, or the terraced strip, the width of the strip is equal to 3.5 feet. And that's using the intersection tool. Now, be careful. Sometimes when you go to look for the intersection, sometimes the little star, the little blinking star, it's not on your screen. And if it's not on your screen, you want to go down here and see what the x and the y values are. So like if the y value was 3000, that would mean that you were way up here off the screen somewhere. So you would have to use your arrows to back up down the graph. You have to be able to see that little star and make sure you're on the right curve in order to be safe. So the answer to this one, which was number 6, is that the width is 3.5 feet. And don't forget that we need to go back and we need to create the window on the assignment, and we need to say what our x min was and what our x max was, y min, y max, and we have to draw in the graph that we just used and label this point. Okay, so make sure you fill that in as well.